Hi all, it's Dave Giles here again for the next lesson of Cambridge International IGCSE Physics, P2, Thermal Physics, and today we are looking at infrared radiation. And I want you to describe how he travels via infrared radiation. So, what produces infrared first? So, it's emitted by all objects, but is not visible to the human eyes. The hotter an object is, the more infrared it emits. As objects get hotter, visible light is also emitted. This can be seen when an object glows red hot. So this here is an old-fashioned hob. You'll also see it if you've got an oven or a grill. You'll see it, the top bit, the element at the top glowing red. It can be detected by special cameras. A thermogram shows how objects with different temperatures emit different amounts of infrared radiation. Here, the white areas are the warmest and the blue areas are the coolest. And you can see this is the person, the body itself is quite warm. It looks like having a sip from a cold drink there. So a few pictures. This here is a toaster. You'll notice most infrared radiation is coming from the center, which is where you're putting the toast. The outside is relatively cool, which is obviously what you want because you don't want to burn your hand if you touch a toaster. Next up, we've got a hairdryer. The very end of it is warm, and the rest of it is cold, the handle, which again is what you want because you don't want to burn yourself whilst drying your hair. And here we've got an ice lolly where you can see the ice lolly itself is rather cold by comparison to the rest of the image, so it's not giving off as much infrared radiation. So all objects give off infrared. The hotter an object, the more infrared it gives off, and that is used for the purpose of night imaging. It's used to transmit signals also in remote controls. And you can test it out yourself. If you've got a phone and you've got a TV remote, have a look at the TV remote, the bit where you point to the TV and press a button on there looking through the camera on your phone. And depending on your phone, you might be able to see the infrared given off. It works certainly with my Android phone, but I know Apple devices have generally got some sort of filter on there, which basically means you can't see the infrared through it. Next question, what is this? Well, it's the sun. And why does thermal energy not travel from the sun to Earth via conduction or convection? So all energy from the sun, thermal energy from the sun is transferred via infrared, not conduction or convection. And that is because, unlike conduction and convection, infrared does not need particles to transfer energy, so it can travel through a vacuum such as space, like you can see here. So which surface will be the best emitters and absorbers of infrared? Well, this can be demonstrated by looking at one of these cubes here. So this is a cube, and it's painted with different sides, different colors. So one side is painted silver, another side is painted matte black, another side is painted white, another side is painted shiny black. And this is called a Leslie cube. And what you can do is you can pour water in and you can record the temperature on the outside. Remember, the hotter it is, the more infrared radiation it is given off. So you pour boiling water in, so you can see the silver side. So the water inside is 80 degrees, but the outside reading is 28. We turn it now to the matte black side. Inside again, we'll go to 80. The outside temperature is going up to 42 degrees. Then we look at the white side. Again, the inside water is 80 and the outside temperature reaches 32 degrees. And finally, the shiny black side. So the inside, it's going up to 80 again. And the outside temperature, pardon me, reaches 38 degrees. So from this, you can see sort of matte surfaces. If we go back to the matte one here, sort of dull surfaces are the ones that are going to emit and also absorb the most infrared. Also, black surfaces you'll see also emit more than white or shiny. So white or silver surfaces are the most poor absorbers and emitters of infrared radiation. So dull, matte dark surfaces are better absorbers of infrared radiation than shiny light surfaces. Dull black surfaces also emit infrared radiation quickly. So which metal block will heat up quicker? That will be the dull black one. And which one will cool down the quicker? It's also the dull black one that will cool down quicker. That is why when you're in a car, if you touch the metal bit of the seat belt, the shiny bit, that is going to be really, really hot because it might take a long time to absorb the thermal radiation, but it slowly, slowly releases it so that even if the outside temperatures start to cool down a little bit, it'll still be quite warm. So let's have a look at some uses of infrared radiation. Okay, so some of these use infrared, and if we skip ahead, we can see that the ones that use infrared are remote control, toaster, grill, optical fibers, thermometer, night vision equipment, and security light sensors. So a few quick questions for you I will go at. I'll let you pause this, and then we'll go through the answers. Okay, which cup of tea will lose heat quicker? It's going to be the dull black cup. If you had a food home delivery business, would you deliver the hot food in dark coloured containers of aluminium foil? Aluminium foil will reflect the infrared and reflect it back to the object where it came from, so it'll keep it hot longer. So it's the aluminium because it's silver and reflects the infrared. Name something in your house which uses infrared radiation. There'll be loads of different examples for that, like I said earlier. The remote controls, the grill, etc. Why do emergency responders cover someone in tin foil that is suffering from hypothermia? Very similar to number 2 here, to prevent them losing more thermal energy. And a slightly harder question, a thermal image camera detects infrared radiation at night. Please use thermal imaging cameras to track criminals running away. Thermal imaging cameras work better at night than during the day. Explain why. Well, at night time, it's usually cooler outside. So at night, obviously people are emitting heat and infrared radiation. So at night, there's a greater temperature difference between the people and the surroundings, so the people are more visible on the camera. Now, what we'll do is have a look at a couple of MCQs, multiple choice questions from paper 2. Which statement about thermal radiation is correct? So let's go through it. It can only occur in a vacuum. Well, it does occur in a vacuum, but not only, so that's not true. It involves movement of electrons through material. It doesn't need a medium, so that's not true. It involves movement of atoms, same as what I said for B. It is infrared radiation. Yes, that one is true. Next question. The tubes inside solar heating panels use the sun's radiation to warm water. Why are the tubes painted black? So let's go through it, starting from the bottom. Black surfaces reflect radiation well. That's not true. They absorb it well. Black surfaces emit radiation well. That is true, but it's not the reason to do it. Black surfaces conduct heat well. The color doesn't affect conduction, it only affects infrared. Black surfaces absorb radiation well. That is true, and the reason it is done. So it is A. Finally, number 3. We've got hot water and cold water and using infrared heaters. The hot water in the black can cools more quickly than the hot water in the white can. The cold water is black the cold water in the black can heats up more quickly than the cold water in the white can. Which row shows the reason for this? So better emitter of infrared is going to be black, and a better absorber of infrared is also going to be black. So the answer is A. Our next lesson is going to be on heat transfer, where we do a little summary of conduction, convection, and radiation. And as usual, I will post the link down below. Thank you very much, and I'll see you in the next video.